A herd of deer were introduced to an island. Their population is given by P of t equals 500 divided by 1 plus 1.5 e raised to the minus 0.1 t, where t is the number of years since their introduction. How many deer were on the island after 2 years? How long does it take the population to double? So here, for number 1, that's a pretty straightforward question. We're just going to evaluate the function at t equals 2. We'll need to think about rounding our answer because this model, is going to give us a figure that we need to round probably to the nearest whole deer. How long does it take the population to double? Well, that's going to make me know how many deer were originally on the island. I need an initial population. And then I'll multiply that by 2. Because this is where they started, and they'll double when they get this number of deer, and then I'll substitute that in and solve for t. All right, we'll start with number 1. So p of 2. I'm just evaluating the function when t is equal to 2. And outside of multiplying minus 0.1 by 2, I'm going to let my graphing calculator do the heavy lifting. 500 divided by, and now I need to be careful. Everything that's on the bottom is going to need to go in a set of parentheses on my older calculator here, so I make sure I'm dividing by everything I'm supposed to be. All right, so I have 500 over 1 plus 1.5 e to the minus 0.2, and we get just about 224, and it says 0.4. So I'm going to tell my reader that after 2 years there are about 224 deer on the island because, well, we shouldn't count in tenths of deer. In this model, we should treat it as a round to the nearest. All right, so now I'm asked, how long will it take the population to double? So I claim we first need to know a value for p of 0, an initial amount. Well, if I think about it, I plug 0 in, that's e raised to the 0 power is 1, so I just get 500 divided by 2.5, and when we take 500 and divide it by 2.5, we get 200. So initially there were 200 deer on the island. So what we're really asked is how long is it going to take for there to be 400 deer? So now I get to solve this equation. 400 is equal to 500 over 1 plus 1.5 e to the minus 0.1 t. Well, I'm going to need some more space to solve that equation, so just move on to our next board. My first thought is I'm going to multiply both sides by this denominator so that I don't have a fraction on one side anymore. And I have a choice here. I can either distribute the 400 and then solve the equation or divide both sides by 400. And it doesn't really matter which way you do it. I'm going to go on divide by 400 and get a 5/4 on this side. Take 1 away. That'll become a 1/4. And now I need to divide that by 1.5. Okay, so e to the minus 0.1 t is equal to, well, that's actually a 3 over 2, and so that would be a times 2/3 when I do the division. I'm going to get a 1/6. Can rewrite this as a logarithm. So this would be a log base e or a natural log. You can also imagine taking the natural log of both sides. divide out that 1/10, that minus 1/10, and here I'll let my graphing calculator help me out. I have the natural log of 1/6 divided by minus 0.1. And so I'm just going to go on and say it's pretty close to 18 years to be the doubling time. So it'll take about 18 years for the population of deer on the island to double.